Hey, and welcome back. Now that we're into out of the mini course, we're going to deep dive on a couple of really exciting topics. This session is going to be on data storage, backup, and roaming. This is going to be really fun because there's a lot of new stuff, not necessarily new APIs, although there are some new APIs, but the way that data storage works, especially the roaming data storage, connecting your phone device to your tablet device is really exciting.
It's one of those real exciting convergence things where we can really do some cool stuff.
It is really, it's really a lot of fun to demo, and it's a lot of fun to show, and it's just it's one of those exciting moments. This is really working. It's really real. We're talking about an app that lives genuinely across all devices. So we're going to cover a lot of different topics. We're probably going to go a little fast because there's just so much to talk about with data storage and roaming. We're going to talk about settings. We're going to local settings. We're going to talk roaming files and settings. We're going to talk about the Windows Storage API. How do we serialize objects in XAML and JSON? How do we store information onto SD cards for our application data? So how do we get to that information? How do we store to it? And then we're going to talk about a concept called known folders, which I could try to explain, but makes more sense after we've covered all the other stuff to cover known folders. And you'll be able to see what a really powerful concept we have in the known folders API. So let's get started with app data locations. There is a lot of places an application can get data from. It can get data from a network through either a direct connection to that network or through to a database or a service, or through a background transfer. We can use file picker APIs to go to the file system, which can go to OneDrive, and we can pull files into our application that way.
We're going to be talking about them in the end of the next session.
Yep. We can go to our known folders, and these are folders like our pictures folders, our video folders, our music folders. There are versions of these on Windows as well as on Windows Phone. We do need some direct access needs in the manifest to say, hey, I want access to these things. We can read or write to the SD card if there's an SD card on our system. There's a installation folder. This is where all of our app information on install goes, and this is read-only. We have application data folders. No! Sorry. I'm sorry. I'm trying to get rid of this pin at the top, and I am not sure where. Okay, it's going to live there for now. Application data folders, and we have three kinds of those: the local folders, roaming folders, and temp folders. And then we have Credential Locker, which is a secure place where we can store our password information, username and password credentials. And this also roams. Now,
I was going to say, I think one important thing to pick up on this is that actually those local folders, the app data folders, that is the local storage. It's like it's private, like storage area.
Right.
And yet the known folders and the file pickers, they allow you to go outside of the sandbox and get at stuff that's not private to your app.
Yep. Yeah. The stuff in the circles is all stuff that's to our app inside the sandbox, and then everything from the networks over to the right is stuff that lives outside of our application. And we're not going to cover file pickers, as Andy mentioned. He's going to cover that in a totally. It's enough information for a totally different talk.
Next one, in fact.
And we're not going to talk about networks and background transfer.
I'm doing that tomorrow.
But we're going to talk about everything else here.
Well, you get going.
Right, yeah, so let's get started. Go. So first of all, a quick overview. The package manager installs our application files into the installation folder. This is read-only access. And the reason this is read-only access is because we're going to write over these files when we update our application. And so we don't want to write anything in there that we're then going to overwrite the next time we do an update. And so if you have something like a database that you're installing with your application, it's not going to be writable because you're just going to overwrite it with the next install that you do. More helpful for reading and writing are the application store data in the local folder. Here we can write settings and properties using the app dictionary. We can write unstructured data into isolated storage files, and we can write structured data into database files. So we have a bunch of data storage areas, and I'm going to go do an overview of those. The first one is our local storage area. This is kind of the normal way of saving data. Should be considered your default way. You can use all the space on the phone. There's no restrictions on how much data you can store in your local folders. And this sticks around from update to update. So if you update the application, the local folder and settings just gonna stay there. The roaming folder and settings is a limited amount of space. It's about 100K, and it's saved to the user's OneDrive, even though it doesn't take up any of the user's OneDrive allotment. So it's kind of free information that the user can get on that they get on their OneDrive that's dedicated to each application. It is accessible by any instance of your application that is opened on the user's account across any number of Windows and Windows Phone devices. And so that's where the roaming settings and folder becomes really valuable, is the fact that local lives on your phone, or on your either on your phone or on your tablet or desktop or laptop application, but the roaming lives everywhere, and it gets updated across all of your devices.
So in many ways, where with Silverlight, you would have just used the local settings for anything that was kind of settings related.
Right.
Actually, the roaming settings almost becomes the default for most of this stuff, because it's usually about personalization, and you want that personalization stuff, their preferences and things, that needs to roam across all the devices.
Yeah,
so you should use the roaming settings first, unless it's really specific to where that app is running. Then you use local settings.
Right, and you can use the roaming settings for any number of things. If you have a similar navigation path on your phone device and your tablet device, you could save your navigation information. What page was I on last? Open that page up on my tablet. Then there's the temp folder, and this is just temporary storage. The scenario that I keep coming back to with temp is if you're loading up a bunch of tweets, you load them and you want them to be there the next time the user is there, store them in the temp file, because after a certain amount of time, they don't care. And when there's a low storage condition, the system's going to go through all the temp folders of all the applications and start wiping them all. Now these three areas of storage all fall under the Windows.storage.application data API. But there's one other place where we can store information locally, and that is inside the Windows.security.credentials. This has a construct known as a password vault, and this is a place where we can store credentials. It's got a credential locker. It's secure storage for password credential objects, which are usernames and passwords. And this is fun because this is also data roamed across multiple devices. So if you do log into a system on your phone, you can take that login information and apply it to the application that's been installed on your laptop or desktop or any other Windows device or any other Windows Phone device. So the application data namespace provides access to these three storage folders. And there's really kind of these 5 places to store the data. There are 3 storage folders and 2 settings places. The storage folders are an object that represent a folder, and you can use it to access folders and files and content and that sort of thing. It's kind of a traditional file storage system. The settings, local and roaming settings, are application data containers, which represent just key value pair settings dictionary. And so this would be very lightweight storage, strings, or very, very lightweight objects that you would store inside of your settings. So let's talk about local and roaming settings. Using local and roaming settings is actually almost identical, except for the fact that one's local and one's roaming. The code for doing it is we say, what's our setting is settings.values, and give it a key, and then give it a value. The value can be any sort of object, and we can simply remove that by using a dictionary .remove to remove any sort of any of the settings that we've stored.
So you don't have to. There's no save method to persist it.
No,
like we used to have to do with Silverlight .NET APIs.
Yep.
It's just persisted.
Yep. It's super simple, super lightweight. I think part of the goal is you don't want to have that sort of async await. Going to a folder, going to file, pulling it up, because the settings might also be a good place to store things like the transient information that we were talking about earlier. So the roaming settings in the roaming folder is all about having one app on lots of devices reflecting, using and accessing one data set. If we publish two versions of our application, one for Windows Phone and Windows Phone and Windows Store, we can roam all that app data across those different devices. All we have to do is assign the same package family name to each version of the application. This takes the form of a folder, a settings dictionary, and they're just automatically stored on your OneDrive. It's limited to the application data.roaming storage quota, which we said is about 100K, but you can query that API and say, how much space do I have left? How much space do I have left? And when that space is gone, nothing breaks. Your roaming settings aren't being saved anymore.
They just start acting like local settings.
Yep, they just stop working from device to device, but they'll still work on your local device. So, when we save something in the roaming settings or the roaming folder, the sync engine transfers that data over to OneDrive based on sets of triggers: user idle, battery, network, lock screen. And then it saves that information, and then the other clients are updated. Usually, this will happen when the application is launched, but maybe it could even be happening as the application launches. And so, if you in some interesting situations, you could have the same user account on multiple devices, and it could just update in real time. That's not actually even an ideal scenario, but it could happen.
Yeah.
Using the roaming settings is really just as easy as using the local settings. We simply have our application data container, roaming settings, and we just save a value to it. And then that is a persistent on the device, shared with other devices. On Windows 8.1, if you've used the roaming settings on 8.1, there's a high priority. Say this is a key setting value. I want you to store it now. Do it now. That won't do anything on Windows Phone.
Yeah.
Reading the roaming settings is just like reading the local settings. We just call that value. We can call it down. And we'll have to cast it. In many cases, if it's a string, that's very easy to cast. So this the name space the key name that we use is going to be reflected across multiple devices. We can go ahead and listen for when that data changes using this data application data.current.datachanged event listener. And this is that sort of scenario where you save something on one device and the application is running on another device, and it just updates from device to device. This will be fired only if the application is active at the time of the change.
But typically your app, when it's launching, it'll be reading out of roaming settings, so if it's changed in the meantime, it'll pick it up.
Yeah, that's just for when the application data is changing while you're running the application.
Yeah.
So we can store that data in the roaming folder as we would on any folder, any device. All the sync takes place in the background. It's good. What is it good for? Like you said, it's good for theme customization information or some basic user information. I would say that it's good for like a user avatar, but avatars can usually be more than 100K, so probably not, right? So no icons, don't put images in there. Basic data and simple information about states, where you are in the application, how the application looks. Maybe permissions for geolocation or something like that. The synchronizing is very, very simple, and it's the last writer wins. So if you wrote on the phone and then 2 seconds later you wrote on your device would they both sync up, and the synchronization would just say, okay, who was last? That's the winner. We can install an application on multiple unlocked devices. We can debug the roaming folder with a device connected to the PC. But when we're locking it, we need to make sure that all our files are stored closed correctly. I really just want to jump into the demo. Really, I don't want to talk about it anymore because this is a fun demo, and it's a really exciting API or a really exciting platform to feature to show off. Okay, here we go.
Cheese warning. Now I have to jump in here for just a second because my good friend Mr. Robert S. Miles, Windows Client MVP now, formerly Windows Phone MVP, and before that we were all Windows Mobile. He obviously he wrote a lot of demos. He worked with me on a lot of the early jump starts, and all these demos always involved cheese. And he did actually do some work. So thanks, Rob, for the work on this module, because cheese has made it into the jump start, which is good because it wouldn't be the same if we didn't have any cheese. So
there's
cheese warning.
Cheese warning. Yeah. Okay. So here we have two applications. We have one for Windows 8.1. We have one for Windows Phone. Now, you could build this as a universal application, no problem, but you can also build it as two separate applications, and the key to this is that we have this package store association. So you can't test roaming data across multiple devices unless you have associated your phone and your Windows application with an ID in the store. So, just a caveat there. So we're going to go ahead and run this on the local machine here. I have it pop up. Oh, come on. Let me see if I can minimize, restore down. Is there any way to get rid of this? Okay, I'm gonna jump back out for a second and change the main page.xaml so we can actually see all of our UI. That's really disappointing. I'm sorry about that, everyone. I have to stop the application. Okay. I'm just gonna give it a big margin.
Because of this blue bar that's...
yeah, because of the blue bar that I don't know how to get rid of right now.
Yeah.
Okay, run it again. Okay, so we have two options. We have out of cheese and cheese maintained. Right now the cheese is secure. And so if we skip over to our phone application, we're going to run this on a device, and this does need to... you could run this on an emulator, but you would need to log into your application. If you run on you would need to log into your Microsoft account,
which you can do within the emulator. You can go into settings and accounts and enter your Hotmail or Outlook.com or whatever.
Yep. But for this case, it's just easier to run this on the device. So I tap this out of cheese warning. I'm out of cheese. I need to panic. And if we wait, and so we're going to try to trigger that event. That update by locking the application. When we do that, here we see this is our Windows application. We had registered that event so that when the data changes, we want to update the status. And so we can go to update status. You can run it, and if we jump back into our application, we see that setting has been persisted across the application onto the other device using roaming settings. And so that was it was like 3 lines of code to save that setting, and then an event handler to handle the change. And now we've synced data between our two devices.
Yeah. That, you said about needing to associate the app with the store. So it's probably just worth saying that you need to do that. You just need to right-click on your project. In Visual Studio, and there's a menu option for associate this app with the store.
Yeah, as long as you
have the same name.
Yeah, as long as you have a developer account, you can you don't even have to go to dev.windows or dev.windowsphone.com.
You can do it from Visual Studio.
You can just right-click and do it from Visual Studio.
And you just need to make sure your phone app and your big Windows app have got the same name.
Exactly.
Yeah.
So, moving on from the local and roaming settings and folders, we're going to talk about a little bit about file access. There are a lot of different ways to access files. There's just a simple table on accessing files. So this is file access for information and files that we've stored on our local, our roaming, and our temp folders. We can use the MS app data to get the app data folders and MS app X to get the installation folder. So
Yeah, you've got these two flavors, haven't you? You can use you can use these these weird URIs to get at it, or you can use the direct storage folder references like you got at the bottom there. So
The interesting thing about the URIs is the URIs will actually work with images as well. So you can take those URIs, and if you have an image that you've stored somewhere, you can connect to it directly in your XAML using this URI. You can also use it to drive your live tiles. And so that's one of the benefits of the URI system for accessing this data. Keep in mind the MS AppX for installation folder. I use that all the time if I have data that I want to preload inside of an application. So to write a complete file, we need to open up our storage folder. We need to create a new storage file within that folder, and then we can just use file.io to write to it.
These file.io APIs are really cool and really simple, simple to read and write to files with those. Yeah, we didn't.
And they're all.
We had some storage APIs in Windows Phone 8. Those were some of the few that came over in the first.
The converged.
But the file.io ones sadly were not there, but they're in now in Phone 8.1.
Yep, and they use the full await async method so that it makes it very easy to do file writing even if you're writing large files. So we'll set our target folder. We can set an action to replace the file action if the file already exists. And then once we have that file in there, we can read it by grabbing the folder that we want and giving it the file name, and we can just read that into a result. So let's take a look at writing files. Stop all the applications I have running. And open up. Open up this new one. Okay, so we're just going to go ahead and run the application quickly. I'm going to run it to my device. And we can type some stuff into the text, into our text stop, some stuff, and we can write that to our file. And of course we can read, stone stuff, that's good too. And then we can read that back from our file. Let's take a quick look at how we're doing that inside of the application. And it's surprisingly just like the code that we saw inside of the slides. We grab that folder, in this case a local folder. We create a file in that folder. And then we simply write to that file. Very simple 3 lines of code. And reading it is grabbing that folder, giving it the file name, and reading the result out.
By the way, you know that blue bar on the top?
Yep. Did you figure out how to get rid of that?
There's a pin thing up on the top left.
I've been pushing the pin.
Oh, right, okay. It's just broken.
So,
yeah. That's kind of weird.
Yeah.
Live with it.
It makes me sad. Okay. All right. We'll move ahead. So in addition to the simple strings, we can also use these streams to write to file to the file I/O. And the key concept around strings is that they're sorry, I'm kind of losing my place here. They handle the difference in latency between one type of storage, the memory, and the other type of storage, the network or file system. So we found it's important to help developers understand storage file and storage folder these are the analogs of like path names and not file handles. Streams are the analog of file handles. So when we have an open stream that the file is open, having the storage file does not hold the file open. The file I/O and the path I/O APIs encapsulate, they open and close. So you don't see it here, but you do see it with the streams.
Yeah, so yeah, we've got this open transacted right here, async.
Right. So using the streams, and I think the streams is how we would do things like saving image files, those larger files to storage. But we'd open up that storage folder, we'd open up that storage file, and then we'd use the storage stream transaction, and that's going to open up a stream for us, and we'll use our data writer to simply to just take that content that we have and stream it into the file. So another demo, this one using using the stream. Come on. And I need about 3 times as much space here. Okay, so what this demo is going to do is we're going to open up a file, and then we're going to keep that file open while we continuously leave it open to write some stuff to it. Then we'll be able to close the file and read it back. So the way, take a look at the code for this. So here's the code where we open up our storage file. And we grab our folder. We open up our stream for writing, and then we can keep that stream open and write to the stream, write to it over and over again. So run that application, pull up the device. It launches, and we can write some things. Oh, open up there we go. Open up our stream at first, write some things. We append that. We can do this as many times as we want. And one more time. And we'll close that stream, and now the stream is closed, it's written to the file, and we can just go ahead and read that file. And we could even go ahead and open that file and write some more stuff to it. Append it, close it, read it. And you see how we get, we open it, we append, we close it, and the stream just keeps that open so that we have an easy way to continue writing to our files. Okay, now let's talk about using XML and JSON serializers. These are important because data. If we want to write something that's more than just a simple string, we're going to probably not want to build up an entire XML file or JSON file by hand. So using these serializers is going to let us build, save objects and data that's a little more complex than simple strings.
Well, it's a key part of what I was talking about in the last module, where you've got some, we've got some objects in memory that obviously, and when you're working with collections of objects, they're all in memory. But then when the app suspends, you need to resave all that data back down into a file, and the way you do that is through a serializer. Yeah.
Right, right. And so this will just take all of our objects, turn them into text. We can save the text and then simply read it back. So there are a couple of tricks around serialization. The objects must have a parameterless constructor. If you have a structure that takes in parameters, then it's going to fail at a serialization. Private and static members of that class are not going to be persisted because they're private and static. The serializer is not going to be able to read private, and it's not going to be able to construct static. So if we add members to the class,
well, this is the upgrade scenario. You need to obviously be careful about if we ship a new version of the app and you've added some new fields to it,
right,
and then you try and restore a file that was serialized before the update. Well, you've got to handle that situation.
Right, and this is actually more of a problem with XML data than it is with JSON data. The JSON data contract serializer tends to be a lot more forgiving. Yeah. Especially if you're adding more parameters as opposed to taking them away.
Actually, we don't mention it in this deck, but that thing about versioning, there is some stuff in the application data namespace. You can get the version, your current version, and set a version.
Oh, that's right,
and it persists that away for you. So you can actually say, okay, I'm version 1.000 of my app, and then on an upgrade, you can actually bump the logical version number of your state data to 1.1.00, and that helps you to keep track of stuff and figuring out in those upgrade scenarios how you're going to do it.
Yeah. So using Serializer is actually pretty simple. We get that stream that we talked about earlier, and we can just hand that stream to our data contract JSON serializer along with an object that we want to save. So I'm sorry, I kind of jumped ahead of myself there. We create our serializer, and when we create our serializer, we give it the type that we know we want to serialize.
So customers here is an object that actually is a collection of customer objects.
Right.
Yeah.
Right. And then we say this is the type we want you to serialize, and then we give it the stream we want to serialize to, the stream that we saw pulled up in the storage in the stream demo before. Where we grab the storage and we grab the stream of the file. We hand that stream, hand the serializer the stream and the object, and it'll just write the object to that stream in a serialized manner.
In that way.
And just like that.
Just like that, yeah.
So the read process is pretty simple, same sort of thing, where we create a serializer with the certain type that we want to deserialize. And then, as we saw in a previous demo, we need to read that object in and cast it as the type that we want to get back. In this case, we're casting it as the customer's object. XML serialization is pretty similar. We create our XML serializer the same way we created our data contract JSON serializer.
And there's no real reason to use one or the other, is there?
Well, JSON tends to be a more lightweight format, so it'll work a little faster.
I mean, sometimes I guess you're going to you might serialize some objects and then send that over a network. You might do it. So
in many cases,
one or the other. But
personally, when I use the XML serializer, it's because I'm dealing with some sort of API, and not necessarily with file types. Otherwise, I'll use JSON, the JSON serializer. So a little bit about credential lockers, which is that last way that we can save, last funny little space where we can save data. The credential locker is created to securely store and roam the credentials that we have. And so it's an API to store just username, password credentials in a secure way. We're talking secure storage, we're talking credential isolation, and essentially we're talking roaming. So apps can only access their own credentials. That's important, right? We don't want anybody to be accessing your credentials, some other application credentials, and we don't want other applications accessing your credentials. So we have our first application, and it sends some credentials over the credential locker. It creates this app sandbox boundary, so that another application, even though everything's being stored in the credential locker, where you're not going to have cross-app pollution of credentials.
I guess what you were saying is the credential locker is kind of like an OS service, in the same way that the roaming data is a kind of an OS service, and it's doing all that for you.
Yeah. So they're saving the same place, but it is secure and it's parsed out. And then the fun part. Credentials roam across devices, and this is really exciting because if you have services that your application is using, and those services require these credentials, you have to log in one place, not across 1,000 devices, and you'll be able to use that service with the credentials that you've stored. So Credential Locker is different than our storage APIs, it's different than our settings APIs, but it's still pretty simple. We create a password vault for our application. We create a password credential, and the password credential actually works very similar to that key value pair. But instead of a key value, it's a key, a username, and a password. Then in order to retrieve that, we call our password vault, and then we can find the resource by the resource name that we've determined.
There's a few other methods on it as well for getting them out, but essentially it's just another string-valued dictionary.
Right,
Yeah.
right. So. The one that's been specifically designed to A, roam, and B, be secure.
The roaming's cool, yeah, as you say. Right. You can do login on one and then pick up your tablet. Oh, I'm already in. That's
right,
cool.
right. Yeah. No, I'm going to have to start doing that on my tablet because all my passwords are too long to put in on a phone. So... the last storage space we're going to talk about is known folders. Known folders is pretty fun. It's an API that simplifies the view the developer has of accessible user data on the phone. So we're not talking about data that's been stored by the application necessarily. We're talking about data that's been stored in our pictures, in our videos, in our music folders.
So this is the user's data. You can call this user data rather than app data.
Yes.
So.
Yep.
Yeah.
And the neat thing about known folders is that it will access known folders on your the default device as well as the SD card. So you could put an SD card in with a bunch of music files, and it can automatically be known by the known folders and included in that. You don't have to. When you take the SD card out, it just gives you back all the available data. So. It's kind of, so we can use the file open picker, and this will also give us access to these known folders, or we can just pull known folders straight into our application. As I said, it combines this sort of internal storage with the SD card storage. So if we say, give me the known folders for all the pictures libraries, it's going to get our internal storage picture libraries and our SD storage picture libraries, and combine that view into a single view. And getting it is just really, really simple. All we have to do is say, here, pictures, await, my windows.storage.knownfolders.pictures, video, music, camera, whatever, .get files async, and it'll give us information about all the files inside of those folders. So let's see how that works. I actually let me see, I might not have pinned that demo. So, yep, there it is, okay. Okay. So here is our known folders. And what we're going to do is we're just going to list pictures that we have inside of our camera roll on the phone. And we're going to put all of those into one by one into a list box. This is one of those cases in which we do want to use a list box, which is you're running a demo. I'm actually going to put a breakpoint there, and we ask for the pictures, and we actually look at our pictures, and you see we have the count, so we have access to every single one of those images. We run it, and oops, there we go. And here are all of the file names for all of the images that I have on this device. And we can do that for video, we can do that for pictures, we can do that for music. And it's one of those APIs that's just really fun to work with because it's really easy to explore. Here are my documents library, here's my music library, here's my pictures, my saved pictures. If I want specifically to target my removable devices, it's right there. Now,
but it's worth mentioning that documents library actually is kind of not as valuable as it sounds. So.
We're going to get to that. There's actually another demo around that. Yeah.
Oh, okay.
The other thing that we need to know is that if we are going to access the user's data, we do need to go into our capabilities. And you see here we have music, pictures, videos, removable storage. If we don't have removable storage checked, we're not going to be able to see the pictures on the removable storage. If we don't have pictures library checked, we can't see the pictures library. The user has to know, because this information is something that they see when they download the application. They have to know that our application has access to their library.
That's really what capabilities are about. Is when the user installs the app, it's up front, it says this app is going to access your pictures or something. And then if they don't like that idea, they could choose not to install the app.
Yep.
That's kind of what it's about.
So we're going to look at using the SD card now. And this is all about reading, writing information to and from the SD card. Our phone applications now have read-write access to that SD card, and we can store our own files and also make use of files that are already on the card. This means that we can create a way where applications can share data amongst themselves, data that doesn't necessarily live inside of the video or inside of the images.
That's kind of good, because in Windows Phone 8 we could read from an SD card,
right,
but not write to it. And now we've got writable access as well. So
yep.
that's really cool.
This is also a fun one. There's full SD card support in the emulator. That's because the SD cards represent this shared resource. Because it represents the shared resource, there are file associations in the manifest that we have to declare. And this is what you were alluding to earlier, which is that we can write, but we can only write to file associations that we've said, I have access to this. And we'll see what that looks like in just a second. So we, like I just showed, we need to check that removable storage device, make sure that the user knows we have access to it. If we're using the known folders API, just as we saw before, pictures, music, video.
But it's important to mention that you don't need to use the known folders. You could just use the regular.
You could just write to the SD card.
Yes, that's right. Yeah.
Yep. But we do need to, if we're taking. We do need to make sure that we are registered for those file associations, the files that we are going to read off of the SD card.
And by a file association, we actually mean the file type, essentially.
The file type, right?
Yeah.
Right.
Yeah.
So, and that file type is an association set in the manifest, and it's set here. We have these declarations, file type associations, and we can set the properties and say, okay, I have access to .txt files, or I have access to .mp3 files. But we have to. This is an explicit. An explicit set, and part of this is that if you have some sort of customized file association that you're used to using for your application, we don't want everybody to just go in and browse all the files. If it's something that you don't want completely visible to everyone, but perhaps you have a suite of applications that use it, you can still access all those files, but you have to know they're there.
And you could create, a lot of apps developers to make use of this. If you've got a custom, your own custom files, you invent your own file extension as well, and that will only mean anything to your app, of course. So,
right.
Yeah. So this is how you do it. It doesn't have to be a .txt or a known file extension at all.
No. So getting the SD card is, we actually kind of saw that in the IntelliSense of the known folders, where we can take the removable devices and get it into this device's var, and we can just, we get that folder, and then we check to see if the SD card.count is 0 or 1.
There'll never be more than one, not on current hardware.
No,
anyway.
there is not more than one. It will only be one.
Or 0.
And then we can just use it in any of the ways that we've seen before. We can use the stream, we can use the simple text write. Is just like any other device or any other folder that we write to. And we can insert SD cards into the emulator. And this is what the demo is going to be around. This is really pretty fun. Just define a folder on your laptop, desktop, wherever you're doing your development. And it will mount that folder as an SD card in the emulator. And then you can start saving information just straight to a folder inside of your on your file system. Once you insert the SD card, it's going to create all those known folders: the document, the music, the pictures, the videos. It'll create all those folders and pictures that you take on your emulator, videos that you take on your emulator. It'll store those into that that folder system, and then we can eject our SD card. And start look. We can actually poke around inside the folder system, look at the files and folders that we've created. So, looking at that from a demo perspective, okay, and this one has to run on the emulator because we're emulating the SD card. And we can take we're going to take a bunch of information. I'm trying to remember where it's saved, but I honestly don't need to know where it's saved, because I'm just going to write this information and read it back. Oh, right. I'm crazy. I'm giving a demo on SD cards, and I didn't mount an SD card. I should do that first.
Yes, that might help. That's what happens when you don't actually have an SD card in your phone.
Right, yes. If you don't have your SD card, it will break.
Yeah.
So I load mine into the fake SD folder. I insert the SD card. It's going to mount it. It's mounted. I see in my application, oh, I just found a new SD card. Do you want to
well, that's
save
the phone
stuff on
that's
it?
throwing that up, isn't
right,
it?
Yeah, this is the phone that says, hey, new SD card. You want to save your photos and stuff on it? I say yes. And immediately it shows me I have a bunch of space free. Here's how much space you have on your SD card. And it gives them the option, save your music and videos and photos and apps and downloads, so on and so forth. Now we can write to the SD card. And we can read back from it, and we see we have a bunch of customers. It's really smart, really small, really hard to see. But we've got Rob Smith and Jim Smith and Joe Smith and Nigel Smith and Sally Smith and Tim Smith and Andy Smith.
The whole Smith
family.
family.
The whole Smith family is living on our SD card right now.
Yeah.
So we can eject this SD card, and we can open it up in our file system. You see, we have downloads, music, pictures, and we just stored in this store folder. And we can open up the customers.
So the app created that store
The app
folder.
created this store folder. And we can say,
where's Jason? Yeah.
Cthulhu Smith. And we'll save that and close it. Close this. And I have found the best way to do this. This is Jason's store. Is to uninstall the application and reload it for demo purposes, of course.
Mm-hmm.
Interesting. Let's try inserting the SD card and do it again. And we hopefully will see that the file that I just wrote to
Yay! Woo.
comes in, and we have all the data back, having ejected and reinserted.
And presumably Cthulhu's in there, not that you could read it.
Unfortunately it's not, and I was having this problem earlier. I thought uninstalling would fix it, but we can eject and reinsert and eject again.
All right.
So that's the SD card emulation, and it's a great way to test SD card. Test your SD card use inside the application. Make sure that your application still runs, doesn't break, whether or not it has an SD card in it, or just make sure that you're saving particular files to the SD card and reading them back off.
Cool.
And so that is data and storage, and we've actually come in on time on this one. And the next session is going to be on file sharing.
So it's kind of related, So sharing, which is actually really cool new feature that we've got for Windows Phone apps, and the file open pickers, which actually nicely follows on from what you've just been doing. So it's another way of getting at other files outside of the app data. So we'll okay.
And we got
some
little extra cheese.
Yay!
For you before we go.
Yeah, and hats off to Mr. Miles for the cheese.
Thanks.
Thank you. All right. See you soon. All right, welcome back. This is, if you've been with us all day, well, hats off to you and well done. And this is the last session for today. We've still got a full day of content for you tomorrow, and even another half day on the Thursday.
Even more.
And even more. Yeah, and it's all good. This session is a load of fun. A lot of great new features that I'm going to show you in this one. This is about sharing files and data in Windows Phone 8.1. So we're going to talk through a couple of things about app-to-app communication, about file associations, URI associations, just briefly those ones. They're not new features. But the share contract, this is a new feature, and it's really, really exciting. And also the file open and save pickers. They don't sound very exciting, but actually once you start working with them and realizing what they give you and how they work, they're really exciting. So I'm going to run through these topics now. Okay, sharing in Windows Phone 8.1. There's a number of different ways to do sharing. First of all, you can do this URI. This is what is often erroneously called app-to-app communication. It's not only app-to-app communication, although that is one thing you can do with it. But URI Associations is where an app launches a URI, and it's kind of decoupled. It doesn't know who's going to handle it. So it just launches it out to the OS, and the OS looks for an app that is installed that is registered to handle it. And if it's not, if there isn't one, it will take you to the store and say, do you want to go and find an app to do this? So the shell is involved in that, and but also the reason why it's not only app-to-app communication is that it's also used for launching into settings and that sort of thing, or for launching the browser and doing a search. Or actually, you can even there's a URI for launching the mail client and starting sending an email, for example. So there's lots of different uses of launch URI async, but the one that's in the app-to-app communication camp is that you can actually create your own custom URI. Like this example is Jumpstart, and you could have another app that's registered to handle the Jumpstart URI, and they communicate with each other in that app A launches app B effectively and passes it whatever data you've put into that URI, so in the query string or whatever. So that's a simple way of doing a sharing. The bigger brother of that works the same way, but this time you're launching a file. So this ties in with what you were saying about the SD cards. Mm-hmm. So if the receiving file, the one on the right there, has registered for a particular file extension, it says, okay, I'm going to handle .jumpstart files, and then this app on the left launches a file of type .jumpstart, then it will go straight, the other app get launched, and the file will be passed to the receiving app. So you can obviously put quite a lot of data in there. So that's a file association, and obviously you can't, if you're a third-party app, you can't register for .x or .pptx or any. There is a list of reserved file extensions, so you have to look in the docs for that. Yep. But typically for file-to-file communication, you create a custom file type and use that to communicate between two apps, and it's very seamless. There's no. If there's only one app installed, it's as if you are navigating from a page in the source app to a page in the receiving app, and it looks like they're all part of the same app. So it's really seamless and really real nice way of having a couple of apps communicate with each other. The new kid on the block is the share contract. So this is a much more flexible arrangement of sharing than the first two ones. So in this one, the shell gets involved with a share picker, and the UI in the middle there is the OS popping up some UI to the user. So again, the sharer and the sharee are completely decoupled. So this is what the contract bit of it comes into it, in that the sender just builds a data package that conforms to whatever the contract says it needs to, and it just throws it out there. And the OS then puts up a list. It gives the user a list of apps that it knows are capable of handling that particular the kinds of content that the source app is sharing, and then the user picks who gets it. So the sender doesn't get involved. It's the user is in control. They pick the app, and then the app that they choose fires up and handles that content and does whatever it does with it. Facebook, Twitter, or could be your own app or whatever. So it's really flexible and really powerful. So just quickly about file and URI associations. These are custom URI associations. Like I said, you can link those into the core experiences by launching an HTTP, which launches the browser. There's mail to for email and that kind of stuff. And launch URI async, which is an example there where you're launching into Facebook using an FB : URI syntax. And you can use custom ones to launch into your own app as well. A file type, you can launch files into the built-in apps, like you can launch, if you launch a .docx, you'll end up with Word on the phone will fire up to handle it. But also you can do custom file types as well. So here's an example of getting a file from your local storage called mydoc.pdf and then launching that file out. And that will launch a PDF reader app should you have one installed. So that's one example of how you would launch a file to another app.
And if you have multiple ones? Then
So if you have multiple files, apps installed, it will put up what we call a disambiguation dialog. Basically, it says, I don't know, which one do you want to handle this? It'll give you a list of the apps that are installed to handle it. That's different from big Windows, by the way, which in big Windows, if you have multiple apps that can handle it, it will only ever in the control panel, the user controls which app is the preferred app for a particular protocol or for a file type. So then it will just launch that one. You need to register file and URI associations, the receiving side of things. So if an app is capable of handling .recipe.rcp files, which is the example we see on this slide here, we've registered a file type association on the declarations tab in the manifest editor, and there you can just, at its simplest, all you need to do is put the file type in of .rcp and save that, and then that is your app is registered to handle .rcp files. Now again, on the receiving end, what happens when your app is activated to handle a file or a URI? You'll get this for file activation. You need to override in your app.xaml.cs, override a method called onFileActivated in the app class, and you you could be getting launched from cold, so you just need the standard boilerplate code that you normally have from your onLaunched method, where it creates the frame and all that usual stuff. But then after all the standard frame initialization code, you have this bit of code at the bottom here, where it says something like, well, you're going to navigate to the page that's going to handle it. So we're going to a page called bugquerypage.xaml here. And then after you've navigated to it, you then need to pass the file to it. And the way to do that is when you're coding up your bug query page, put a property on it. And in this example, we've called it file event. And then all you do is you set the args, the file activated event args that you've received into this onFile activated method, and you put that value into that file event property on that page that you've just navigated to. So that way you've passed the content onto the page. The page can then open that file and do whatever it wants to do with it. A similar thing for URI activation, where this time you need to override the onActivated method, and there's a number of actual different ways the onActivated method can be fired. So you need to look at the iActivated event args and find out, is it a protocol activation kind? If it is, then you know that the args you've been passed are actually a protocol activated event args, and then you kind of basically do the same pattern you did before. So do the standard frame building up, and then pass those args onto the target page so that it can handle the activation. Now, in the sample code, there is some demos for this, which are kind of interesting, but I'm actually going to move straight onto the share contract in the interests of time. So, yeah, sharing isn't new to Windows Phone. I mean, obviously we had file associations and URI associations in the last release. But we also had these APIs, Silverlight APIs, which are share link task and share status task, but they're a bit limited in what they can do. You basically share a link, well, share a status, the string. So, and the internal apps also had a lot of share UI built into them, but that was only the internal ones, not actually. So you can share through NFC, you can share page, share contact, but they're specific to the built-in apps. So it's all a bit, it's okay, but not as flexible as we'd like. So enter the share contract, which kind of is a new way of thinking of sharing, and obviously this comes from Windows, big Windows. It enables the user to drive the sharing between apps, and it kind of makes it extremely flexible. So what it effectively means is that when the next latest and greatest new social network suddenly goes viral, and we get the app onto Windows Phone, then that will be available like really quickly, instead of having to wait for first-party apps to be updated to kind of be able to share content with this new social network. It'll all just work because we've got this decoupling between the app that is sharing content and the app that is receiving the content, all through this share contact. And we're making sure that it works really well on low-cost devices, the 512 meg devices. That's important as well. We've engineered it to do that. What we feel is that there will be a great many apps. So when you're building an app, a third-party app, if you might think there must be some stuff that this app can share. So whatever this app is doing, if it's doing anything of interest, you might feel that at some point in the UI, you would put a little button on the app bar saying, share, do you want to share this content? And it would share, maybe the app allows the user to take a photo or something, so you can share that content. So many apps will be a share source. Only a few apps will be a share target. So these are apps that are there to be shared to. And the obvious ones you'll think of are Facebook, Twitter, LinkedIn, all this kind of stuff. But there could be others as well. And the mail app for sharing through email, NFC, sharing through tap to share. There are obvious ones that come to mind. So if you think that your app could be could add to that collection, well, great, be a share target. But there's not going to be so many of them. So share source, using this contract, if you implement the share source contract, what you're telling Windows is your app has something to share, some kind of data, which can be quite flexible. It could be files, it could be just text string, it could be images, it could be HTML, there's so lots of other things to other apps. So many apps will be a share source. If you implement the share target part of the share contract into your app, you're saying to Windows, hey, yeah, I know how to handle text. I know how to handle shared images. I know I can do this. So you then make yourself available to be on the receiving end of this. And it kind of helps, this kind of decoupling helps handle this potentially volatile kind of situation where you never know what's going to be the next greatest sharing target. So and you can also integrate with built-in sharing. So there's going to be a lot of the first-party apps, the built-in apps on the phone are going to be share targets. And the obvious one, email, messaging, tap and send, Bluetooth for sending files, OneNote and Room. So you can share stuff with other people in your room. And a lot of the built-in apps are going to be share sources as well, of course. The photo viewer, Internet Explorer for sharing pages, music, Office and contacts. So there's a lot of built-in, and you can actually very easily involve yourself in all of this good fun. So just to reiterate, this is the share contract UX. The experience for this is that on the phone. Now, on big Windows, you will know that you swipe in from the right and you get the charms bar up, and there is a share icon on the charms bar. So that in Windows is how a Windows Store app initiates the share contract through the share. So you've got the built-in UI on Windows 8, which is the charms bar. Windows Phone, you need to provide some kind of UI yourself. So here we've got an example of an app bar button in your app. And now actually what happens is then the user taps that. You make a simple call from your source out to the shell to say, hey, I've got something to share. The shell actually calls back to you and say, oh, what have you got to share? And you say, oh, I've got a picture to share, or I've got text, or I've got HTML, something like that. And at that point, then it bounces back to the shell, and the share picker is displayed to the end user, where the apps that are installed on the phone that are have registered through the share target contract, that they know how to handle the content that the source app is sharing out, will be listed. And there's also this most recently used list as well, because this could potentially be a fairly long list. So the ones that the user prefers to use will be shown at the top, and then everything else is underneath. Once they've selected an app, then the target app is activated, and it shows some transient share UI. So it'll probably show just one page, sufficient to allow the user to confirm or deny that they want this to happen. And then it makes a call back to the share contract saying, yeah, I'm done, and control is returned to the source app. So that's kind of how it works.
So it's so with big Windows, you have the share flyout that comes over, and with Windows Phone, it's a dedicated UI that we go out to and come back to.
Yep,
okay,
that's right. This is how it works in a flow diagram. Weirdly, okay. So what happens is the source app registers with the data transfer manager, or in Windows. Let's get these boxes up. There's something gone wrong with my animation here. It's not how it's meant to be. Right, there we go. Okay, so sorry about that. So what actually happens is that the user selects on the phone the share UI on the Windows Phone. You see the light blue box on the left there. which and then it calls out to the share picker, to the shell API. And if you're on big Windows, it gets to the same place by the user selecting the share charm on the right by swiping in the charms bar from the right. And that gets to the same box, at which point the share picker sends an event, or fires back in events, which to the source app and says, okay, what have you got to share? So it receives that event and fills this object called a data package. So this data package is the formalized way of the contract for the share source, and it fills that and it sends it back to the share picker. The share picker filters the list of target apps that know how to handle that particular data package, shows the UI to the user selects the app, and then it activates that app and sends it the content. So the share target app gets activated for sharing, processes the data package contents, reports complete to the share, and then we return control back to the source. So what do you do in code? What does that mean? Actually very simple from a share source point of view. You would need to, on Navigator 2 on whatever page where you want to share some stuff, you call Data Transfer Manager, get for current view, data requested, that's an event, so you hook that event. So we've got an on-share data requested event handler that we're not seeing on this slide. We'll come to that in a moment. When you leave the page, you need to deregister from that as well. And then at the point when the user activates the UI, like the app bar button, to say, yeah, I want to share something, all you do is call data transfer manager.show share UI, and that is the first call out to the share picker. But the user doesn't see anything yet. Actually, what the next thing that happens is that on that data requested event fires back in the share source, because it's the share picker is going to ask you, okay, what have you got? So you, in your on-share data requested, you fill in, you create a data package, and that data package is passed to you in the data requested event args object that comes into this event. So you just fill it in with data. The simplest way you can fill it in is just set, there's a number of set methods on it. So here we're going request.data.setText, and you put some text into it. You must set a title on this. The description is pretty optional. In actual fact, on Windows Phone, you never see it. It is shown in the sharing UI that's displayed on big Windows. So you fill that in and give it, and then obviously the event handler completes. And at that point, the sharing process carries on. Here's a more complex example of putting some stuff into the data package. This is an example of actually getting a file and putting that into the data package. You'll notice in the middle there we've got an await storage file.get file from application URI Async. So it's reading a file called needle.jpg from the installation folder. So this is one that you've got in the assets folder in your app. This ms-appx, that means the installation folder. Because we're doing an async method in there, there's an await in the middle of that. You need to request get deferral before calling it. And when you have finished building the package, you call deferral.complete. It's similar to the thing we saw before. So you need to use deferrals to when you're doing any async work. Set the title on the data package, space needle, optional description, and then you need to set your storage items to the file. You can set a web link as well if you want to. There's a lot of set stuff you can put into this data package to describe as fully as possible the content that you're sharing. In fact, this is a long list of all of the set methods that you can use to put stuff into that data package. You can set an application link. This is a URI link. This is the same as this URI Associations we were talking about before. You can put one of them into the data package so that the share target could, if it wanted to, call back into your app using the URI Association for your calling app to do something else. Wow. Think about that for a second.
It's like Inception.
Yeah, and then set bitmap. You can put a bitmap in there. Set data. Set data provider is interesting. Well, if you want to put some stuff in the data package that's going to take quite a long time, then actually what you can do is kind of actually declare a callback method into the data package, but don't actually supply the data itself at that point. So what happens is the data package goes over to the share target. The share target then calls your callback method, and it's at that point later on that the content is sent on. So this is a way of handling long-running stuff, and you can kind of put better UI to the user to tell them what's going on. You can put some HTML format in there, some RTF data, and storage items, files or folders in there, or text and web links. So very, very rich what you can put in there. We have demo, sharing source. So let's go and get that up. Oh, I need to sign in everywhere. I've been talking too much. All right. Okay. That's on there, and I should get some stuff over here to help me do this. And I could even spell it right. Okay. So I've got a. Let's go off to what session are we on?
10. This is 10.
10. Here we go. So it's a very simple little app. This. Keep it simple. It's always better. So in when this loads, let's a simple sharing demo in main page.xaml.cs. Let's just have a look at the code. What it takes to be a share source, not very much, actually. I mean, obviously, if you get more complex about the data you're storing, and I've got a nice demo of share source in the very last session of this whole Jumpstart, session 23, which is about Silverlight apps. Because all this is available for Silverlight and for Windows Runtime apps. Let's not forget that. So here we go. On Navigator 2, we've got Data Transfer Manager, get for current view data. We're going to hook into the data requested event there. We're unhooking it on Navigated from. We are, at some point, we've got an app bar button where we're going to call show share UI. And when the share picker wants to know what it is we want to share, then this is going to fire in here. So all we're doing is, well, we don't actually need a deferral really, but it's good practice to no harm in doing it because there's no async calls in here. But you must set a title, and all we're going to do is put some text into it from the screen. So let's actually just run that on the emulator. And here's our really, frankly, stunning app. Put some text in there. By the way, anybody who doesn't know how, if you want to actually use the PC keyboard, if you do...
you should be able to just type with the... Oh, okay.
Can you do that?
With 8.1, you can just type.
Oh, right. Okay. So Matthias has just told me something. I didn't know. I'm supposed to be the font of all everything 8.1. But yeah, in Windows Phone 8, you actually had to put... You can still do this. Page down hides that.
Yep.
And page up puts it back again. But Matthias tells me, actually, all I need to do is type... Oh, my God. Wow. They just thought of everything in this release. That's so cool. And there's my little share thing down on the app bar. I'm going to hit the share. Now, this is the shell. This is not anything to do with my app. This is the shell saying, oh, OK, who do you want to share it with? And I say, oh, I'm just going to share it with OneNote. So we share it with OneNote, and the OneNote share target has just stuck that text into a quick note. So you can see how OneNote has handled text. If I put images in, I guess it might have put the image in there. I don't know. I haven't tried that with OneNote. Depends how the app's built. So you've already got 2 share targets built into the emulator, simple ones for text sharing. So that's the demo. How stunning was that? Woo. Yeah. All right. What about the other side of the coin? If you want to be a share target, I say not many are going to want to do this, but in this one you need to put in your manifest. You have to register what it is that you understand. You can absorb. What kind of content can you handle? And as there's a list there on the left of the different kinds of data formats that are supported, and these are the ones you can register into the manifest. You'll see in the right there, this is the UI from the manifest editor, where you can enter one or more different ones of these data formats, and you just keep hitting the add new to add more. So you just do that, and also underneath there is the supported file type stuff as well. So for files that are shared, then you can enter them in there as well. So different kinds of data formats and different kinds of files that this particular kind of app knows how to handle. So again, you could use this as a way of passing custom files between a source app and a target app as well.
Yep.
And if there's only one app, if there's only one app, I guess it will just go seamlessly across to the shared target.
Yes.
Yeah. So yeah, that share picker UI only comes up if there's any ambiguity about who might want to handle it. So there you go. That actually is the registration side of things. Now, what then happens? So once you're registered and the app is installed, thereafter the share picker knows about you, and it will include you in this thing about figuring out whether whether you're a potential target. Now, if you are active, if the user chooses your app, then your app will be fired up, and you need to override in your share target app the on share target activated method. And then we get the whole usual kind of, usual startup kind of logic. And then but then we can navigate to the share page, which is our transient UI. So many apps that are shared targets might even have a page that's solely dedicated to handling share activations, rather than being one of their regular pages that the user would interact with in normal use. So you can just navigate to that page and pass it in navigation arguments the args.share operation, which is that data package. And then in the on-navigated to of that page where this is going to handle it, you get in the e.parameter is the navigation args that were in the on-navigated to, so you know that is this share operation object. So you then just go into that share operation object, and you can pull out the content that was put into that data package. So here we've got an example of pulling out the title and the description. We're getting the text from it, from that particular data package. And there's an example of pulling out a file that might be in a data package, or a bitmap image. So there's lots of different kinds of content that's being pulled out in this specific example. So this kind of works. This bit of logic here, it would be exactly the same in a Windows Runtime app or in a Silverlight app. So all good. But the one thing that's different is that the transient UI must show some kind of thing that the user says, okay, yeah, I'm good with that, or no, I don't want to complete this sharing operation. But in both cases, you need to call the report completed method on that share operation object. This is the indication to the shell saying, okay, I'm done. And that's when it returns back to the caller. So in my project that I was doing just over here, I have got also a shared target in here. So the package app manifest, just to go into there, we go into declarations. Actually, just stop it running. I'll run it again in a minute, so we can see. So you can see we've obviously in declarations there's loads of different kinds. We've chosen a shared target. I'll give it a bit of a description. We have added just a single data format. It's saying, okay, I know how to handle text. We could add more into there. It could be RTF, but I don't want to do that. So you can support any file type, or you can add a specific file type. And that bit actually doesn't matter. So that one we can simply deploy to my target. Let's just deploy it, which installs it onto my emulator. And now if I go back, so going back from OneNote, I stopped it running, didn't I? If I hadn't stopped it running, the previous app would still have been running, which would have been nice. So now we can share something else. And share that. And now our app has turned up in the list there as one of the potential share targets as well. We could share with OneNote, or we could share with our little app, which does this stunning thing, puts it on the screen. You notice I've got some UI on here saying, okay, yeah, I'm good with that, or no, I'm not happy about that. So I'll say, yeah, actually we share it. Now, obviously, the share target app would do something more interesting than simply show it back at the user. In reality, if you're Facebook or Twitter or something, you send it up to the cloud and share it properly. So, but now we're back with the source app again. So nice and simple. That's kind of how it works. Sharing best practices. If you're a share source, share as many different formats as you can, if possible. It just widens both the numbers of apps that you can share to, and also gives them as rich as possible a source, a type of data for them to handle. So they can choose to use any, all, or none of what you send it, actually. So they'll obviously choose the richest data format that makes sense to whatever the shared target is going to do with it. In the targets, just you need to keep the sharing UX. It needs to be a transit UI, so it's going to be like 1 page or 2 pages, and it needs to be completely self-contained. So absolutely no home buttons that are going to send you back to look like completely boggle the end user's mind, because they suddenly end up in some other part of the app that really doesn't make sense when they were trying to share to it. Yeah, think about large data transfers. There's all kinds of stuff that if you're going to be handling big data transfers up to the cloud, use the background transfer API, which we're going to cover tomorrow morning in the networking session. And you must always call that report completed method to send the user back to where they came from. So that's kind of it. Comparing with Windows, this is completely converged. It works both the same way, apart from obviously the charms bar and the having to put your own UI. But the way it all works is the same, complete API convergence. There are a few things that we don't support from big Windows. There's this thing, this idea of long-running shares, and Windows will keep a share target running quietly in the background once it's been activated, so it can be quickly reactivated. That doesn't happen on phone. It's always killed in terms of once it's done, it's done. In terms of making sure that we conserve phone resources. And we also do not support quick links, which is something that's on big Windows. The source application will be suspended when the share is invoked. Again, that's different from big Windows, where the source kind of happens as a transient UI that doesn't hide the source app. But as you saw with phone, we get the share UI is a full screen display, so the source app is suspended. And of course, that does mean while any app that's suspended, if the user goes off and does something else while they're in the middle of sharing, it could mean that your source app could be terminated, so just bear that in mind. You'll have to, well, that's just normal termination. You have to handle that situation. Right, lastly in this module, we're going to talk about picker contracts, which is the file open picker and file save picker. These are actually surprisingly interesting. So pickers aren't new to Windows Phone either. We had the photo chooser task in .NET APIs for Silverlight Windows Phone 8, where you can go and pick a photo from your album. However, in Windows Phone 8.1, the file open picker and file save picker massively, give you, again, it's the same idea with a share contract. It kind of abstracts the things very nicely and gives you, allows you to share, to open files from a wide variety of places and from a wide variety of apps. So if your app on the left there, where you want to click a link that says something like you're going to invoke a file open picker, where you want to go and pick a photo. So at the next point, you get the provider comes up again. So the provider comes up and gives you choices of selecting from the phone, so you can go off to the camera roll and that sort of thing. But there's also an option to look at apps. You can actually go and pick a file from an app. So the obvious choice here is OneDrive. You might want to go and pick something from your OneDrive. So then it activates the target app, and the provider UI then handles the picking operations for you. So your app doesn't have anything to do with this at this point. Your end user picks the file, and at that point, the picked app is transferred back to the picker again, the original app. So again, this nice kind of, the shell is very much involved in this in the middle, in helping the user to select who you're picking from. So the whole point of this is that apps shouldn't care where a file comes from or where it goes to. They also need to be able to access any type of file. It also means that it allows the user, the app, to get at files that are not in its own folders. So again, Matthias was talking about the known folders, and he made the point that in order to use the known folders and the storage APIs directly, you're going to go and open a file in that folder. Sure, you can do that, but you have to declare the capability to say, yeah, I want to go to the pictures library, or I want to go to the music library. So you have to declare that capability. Now with the pickers, you can still go, with the file open pickers, you can still go and pick a file from those, but because the user is involved and has decided and has been totally involved with where that file comes from, you don't need the capability because that permission is implied. So it means actually, it's not just picking files from the pictures library. It can go and get a picture from the cloud or from another app or some other app or I don't know, a Flickr provider app or something. There's loads of different apps that could be the source for that picture that you want. And it supports both open and saves, and it must work well on low-cost devices. Now, in this case, that does introduce some changes from big Windows, which I'll go through. But again, this is all available for Windows Runtime apps and also for Silverlight apps, Silverlight 8.1 apps. So let's look at the client app. Now, on Windows, this is where, on big Windows, and this is where if you're doing a universal app, you're going to have a bit of #if_def going on here if you're sharing the source code, the file that's got this code in it. Because on big Windows, you just new up your file open picker. You can set some properties on it like suggested start location and that sort of thing. You put the file type filter to say what kinds of files you want the user to be able to go and open, to go and pick. And then you call openpicker.pick single file async, and that's an awaitable, so you just wait, and your app just sits there and waits, and then the user picks the file and comes back, and then your app carries on processing it. That doesn't happen on Windows Phone. Now, the reason why we've got this rather weird looking and continue method is that this is the need to support low memory devices. It's all about the 512 meg devices, really. So you start the same way, although some properties like suggested start location and view mode are ignored or you may even, I'm not sure if they fail, but you can't use them on Windows Phone. You still set your file type filters. Then you can set some continuation data, which is just a bit of kind of contextual data, some useful information that means something to you in the app at that point. And then you call pick single file and continue. And at this point, your app is suspended. And of course, potentially may be terminated later on, because any suspended app could be terminated if the whole phone gets under memory pressure. Then the file open picker shell UI takes over. The user picks which app they want to use. They go and pick the file. And then when they've picked the file, at that point, the original app will get reactivated and to handle it. So there's some special ways you have to code it to handle this. At some point, you get back to the same point we were in the Windows app, but there's a little bit of plumbing code you have to write in order to get to that point. So this is that activation after the file picker. I'm only going to handle the Windows Runtime apps case here. When we talk about the Silverlight one, it's a slightly different thing. So on Thursday, when we talk about Silverlight 8.1 apps, I'll come back to this. But for now, this is how a Windows Runtime app. You need to override the onActivated method. We met this before, earlier in this module. And this time, you're looking at the iActivated event args and saying, is this a file open picker continuation event args? Got to be a candidate for longest event args name in the book. If it is a file open picker continuation event args, then we know that this is a file open picker continuation. So we do our normal initialization code because we might be coming back from terminated, so we might have to create the frame all over and all this kind of stuff. And then when we've done all that standard boilerplate initialization code, we then navigate to the page where we initiated that file open picker from, back to the same page where we kind of were before we got suspended, which in this case is a page called profile page. And then we do the same kind of thing before. What we do is we code up on that profile page, we put a property onto it, and in this case it's called file picker event, that property, and the type of that property is file open picker continuation event args. So then we just simply, having navigated to the page, we get that args that we've been passed into this onActivated and plug it into that page. We simply put it into the setter, put it into that property on the page. And then step 2 is in the setter of that property. So here's that property at the top here, the file picker event property. In the setter, then we call a method, which in this case is called continue file open picker, and pass it that file picker event args. So this is the point at which we rejoin the code path that we were doing in a big Windows app. So you can imagine on big Windows app, they've just called pick single file async, and when that returns, they then carry on. So this continuation file open picker method that we've finally got to by all this crazy reactivation and navigating, we're back in the same place. Phew. Saver files just the same kind of pattern. So we got save picker, save file async on big Windows, and it just carries on. On Windows Phone, we've got pick single file and continue, and the same process happens as with the file open picker. By the way, I haven't really explained. A file save picker is like a file open picker, except you go and pick either a file to overwrite, or you say I want to create a new file here, and then it returns to you the picked save file, and then you can fill it up from the save data into it from in the source app.
So it's just like the grabbing a file out of a folder.
Yeah, exactly so.
And then you can write the stream or write to it. Yep.
Yeah, exactly so. Okay, so right, let's run. I need to. What are we doing here? Still running from the previous demo. So let's go and open the next one, the last one. My mouse trigger finger's going quite dead after doing this all day. Okay, so I'm just going to. It's got a file open picker demo, and we've actually got a Silverlight one in there as well, just for interest. But I'll talk about that on Thursday. So here's our app. And I'm going to go off to my profile page, and this is a link, change profile picture. Before I click it, I'll just show you the code for that, which you won't be surprised to see. Here's what we saw on the slides, which is, I'm in the wrong page. This one, which is, here we go, change picture click. We file open picker, we add some file type filters, we put some arbitrary data into there which actually we don't use, and then we call pick single file and continue. So let's do that. So now we're in the file picker. This is the shell that's taken over at this point. Because they were all pictures, it's done a smart thing and says it's taking you straight to the camera roll, because that's probably where you want to go. Actually, we can take a picture. So, okay, let's take a glorious, ooh, that's lovely, yeah, we'll take that picture. And then we've got our picture, and we're back in my source app again, so we've picked app. And we can actually go off to do it again, but this time go to apps. You can choose location. You would see this by default if there was any ambiguity. Now, in here, I haven't got any other open picker providers, but you can have apps could be in here as well, like the OneDrive app you'd expect to be in here. And in time, as more and more 8.1 apps get created, this list will get longer and longer. But there's only the phone, which is you can go off to. Ooh, look, we can go off to all sorts of places if you go phone. So yeah, we can go. Well, as you can see. Anyway, I'm going to go back. So that is kind of a very brief picker. Now, there's a complication or an interesting another element to all of this. First of all, oh yes, comparison with Windows, it's kind of different, and these properties are ignored. Yeah, the picker provider apps, similar to share target apps, you can create apps. An example is the OneDrive app, and I'm not going to talk about that because that's kind of, if you're interested in that, it's all well documented, and we need to wrap this up, frankly. So I'm going to finish just by very quickly talking about the access cache, windows.storage.access cache. What is this? What is access cache? Well, okay, so you've got this app that's using the file pickers, and this allows you to open and save a file at any location. So the source app has got back a storage file object, but that storage file object could be anywhere. It could be in the cloud. It could be attached to app, my best file provider app ever. You don't know, and the source app doesn't need to know because it shouldn't need to know. But if you think about, if the user runs this app and has picked a file successfully from my favorite file picker provider app, they come along and you run your app again a few days later. They want to probably, more often than not, they quite often in these situations want to reopen the same file. So how do you do that? Well, you could show them the file open picker provider again. You could do the whole file open thing, but that would be kind of tedious, and that's a bad user experience. So actually what you want is a way for the user to be able to reopen files that they have already worked with, because they've already said, I want to open that file, because they did it once before. So there's kind of this implied consent to use that file again there. And the way you do that is with this thing called the access cache. More specifically in there's a class called storage application permissions. So every app has two lists. One is called the future access list, and the other is called the most recently used list. FA and MRU for short. So the MRU is where you can put most recently used files and folders into it. And that is a 25 item limit, and it's automatically managed, so when it fills up, it just bumps the oldest one off the bottom. So you can just keep on sticking, every time you pick a file with the file open picker or file save picker, just do it, just put it in the MRU. You may not use it, but you may want to find that you want to use it. The future access list is much bigger than that. It has a 1,000 item limit, but that's not automatically managed, so you actually have to put some code in. If it fills up, you need to manage that and trim stuff out of it. But both of these, what they do is they store a storage file or a storage folder, but a bit more than that. They kind of store the implied permissions with it as well. It means you can pull out, you can get out of this list a reference to a storage file that isn't in the app's local folders. It could be out in the camera roll, or it could be in OneDrive, or it could be in my best file provider picker files data store, whatever that is. I'm going to stop saying that. So the way you use it, here you go. This is continue file open picker. Saving it into it couldn't be easier. You say storage application permissions dot most recently used list dot add, and then you add the file. And you can put some metadata on it. It's similar to add it to the future access list, just add it. So there you go, and that's very easy. And then to retrieve it again, you can go and look into that list, you can enumerate it like that, or when you save it on the previous slide, you get a string token back. You can use that to key into the list and get that out in future. So you could store that token into your roaming settings, for example, or into whatever. So, and then use that to access the list. It's easier to show than it is to describe. This one actually here, oh look, this app actually has on the main page 3 things. So if we go now to profile page and pick yet another, it's going to take a new picture which looks spookily like the other one, because actually that's all the built-in camera takes. But if I go back now, we got 2, because every time I'm picking a file, I'm saving it in the most recently used list, and in my main page I've got some simple logic here. In the load state, I'm going off to the storage application positions most recently used list. I'm picking out the top 3 entries, and I'm pulling out the token associated with each entry in turn. I'm getting the file again, which is not at all in my storage. It's out in the camera roll, remember? And then I'm getting the image and I'm sticking it onto the screen.
And this is all without the permissions required to access the no folder?
Exactly, exactly. Because you've implied the permissions, because the user's already picked this in the past.
Yep.
And the other good thing I didn't mention about it is, it's really cool, is that these lists, they track things. So if, for example, a file was on the storage card and then they copy it back to the phone storage, the reference to it stored in this list will move with it. So you don't lose it if they actually move it around, as long as it's still addressable, of course. Now I'm just showing these images on the screen here, but obviously whatever UI you want to provide in your app to allow a user to go back to, you used this last time, do you want to reopen it? So whatever it works for you in your app. So that is that. So in summary about these guys, this is adding it all up. File associations, yeah, we've always had that actually. And URI Associations, yeah, we've always had that. So we've got that across all 3, Phone 8, Windows Phone 8.1 and Windows 8.1. Share was kind of limited on Phone 8. We had some, but it definitely now we've got the full share contract, so it's really flexible for Phone 8.1 and Windows 8.1. The file open picker and file save picker definitely didn't have any concept of that on Windows Phone 8, but we now have great support for that on Phone 8.1 and Windows 8.1. It's cool stuff, and think about adding these to your apps. You really can make your apps really shine on Windows Phone using all this kind of good stuff. So it's all new possibilities for allowing your apps to share richly out to all kinds of different providers and getting apps from other things, like there's an example. So you can actually really help your users engage with your app in new ways. We're done for day 1. Well, which is great. Thank you very much for any of you who have stuck with us all the way. And if you're still up at this time in Europe, go to bed. We're going to wrap now. There is going to be a poll straight after this. The poll is already up, I'm told. So please, if you can take the time, please take the time to let us know how we're doing, and Tell us if you're liking the content. Give us feedback. That's really important to us.
Yes, please.
And we really hope you will join us at 9 a.m. Pacific Daylight Time tomorrow morning. We have another whole day with great stuff. What are we doing tomorrow?
We're kicking off with background tasks. We're going to cover geolocation. We're going to cover tiles. Tiles is a very exciting one for me. Contacts and calendars, sensors, camera.
Bluetooth LE.
Bluetooth, enterprise. It's going to be a really packed day of a lot of the most, for me, the most fun stuff that we have in Windows Phone. And we'll finish up that day with a great session on tooling.
Yeah.
So,
and again, all that is available. All that's going to be is available for Windows Runtime apps and Windows Phone Silverlight 8.1 apps.
Yep.
So, all cool stuff.
Yeah.
See you tomorrow.
All right.